Pause real quick and copy that. I forgot. Take a look at this new sheet that I handed out to you. We're going to use this as our crutch to figure out the process for solving these problems. I want to point out right away, though, that this roadmap cheat sheet thing, you don't get it on the test. But luckily, your test is miles and miles away. So we've got lots of time to learn how to do this without using this after seeing how it works with it. However, on the back, I want you to see that I've got some conversion factors, most of which you're familiar with, that I do give you on the test. So be aware that we'll be using those. The only new one there is liters. We haven't talked much about volume, but there is a conversion factor for liters as well. Now, before we jump into a problem, though, you'll notice that I've got projected a marked up version of the table that I want you to mark up as well. You see that square in the very middle? All right. The square that's sitting here. Every type of problem that we do will start on the left-hand side of that square. Somewhere on the left of that central square will be the starting point of any stoichiometric problem. And the way you know where to start is based on the given units. If you look down here, it says moles not given. All right, if you are given a problem that is not in units of moles, then you're going to be starting over in this area. One of these three rectangles. It's kind of a broad area because if they didn't give you moles, well, it'll be based on what other unit they did give you. If they do give you moles, though, then you'll be starting here. In the only other area to the left of that middle square. So if moles is given, it's actually really good news because it's a shortened problem. When moles is included, there's less work to do. I'll show you what I mean when we start. Now, while we will always start on that side of the cheat sheet, we'll always end somewhere on the other side of that central square. In one of these two zones. And again, they're separated the same way. If the question is asking you to find moles, you get to end right here in this circle. Right in this circle if it asks you to find moles. But if it asks you to find anything else, all right, down there it says other unknown, then it's going to send you to one of those outer rectangles. Again, if moles is a part of the problem, you get to end earlier, which is why moles is your friend. Anytime moles is a part of the problem, it's a shorter problem. So you're hoping for moles. So when you're done marking it up, please copy down this reaction. Now I want to point out a couple things before we start trying to figure this out. Notice how I've given you a translated and balanced equation. If you look on the other whiteboard, step 1 is for you to find that. I don't have time during this lecture or tomorrow's continuation of this lecture to balance all the equations for you. The assumption, since we've been doing that, is that you know how to do that. So while my examples during these lectures won't make you balance, the online assignments a lot of times will. So you've got to have a balanced equation. Now you know this is balanced because you see a coefficient. All right, if you see a coefficient anywhere, then the whole thing's balanced. I would never partially balance an equation for you. Another thing I want to revisit before we start is dimensional analysis. Put down your writing utensil, put it down, and just look here. We've done some dimensional analysis before with our mole math. Do you remember what thing these two squares had in common? What was the same about them? The same what? The same units. You know, I'll even simplify it. They had the same words. Whatever words were in that, don't write, whatever words were in that square are the same words that were in that square. Did they have the same number? No, they weren't identical squares. They just had the same units. Were these two squares the exact same? No, not in regards to what you wrote in them. All right. However, whatever words were there, hey, where else did those words show up? In the next diagonal. All right? So we had that happening in our other math, and that's essential to understand about dimensional analysis, because the entire point is to make these match so that they cancel out when we run our numbers. So that's an important thing to remember. You can pick your writing utensil back up. I want you to understand the information that we're dealing with here. There's always going to be a section of given, or you can refer to it as known. They're the same thing. Data. We don't have to do this red stuff I'm doing right here. Just for one time, I want you to see what I'm thinking when I look at it. That's my given stuff. And also in the problem, there will be an unknown expression, the item that it's asking you about. So understand what we're doing here. It's saying, hey, if you were going to go to the back of the room and do this reaction, and I was going to give you 150 grams of that reactant, how much of him would you make? And we can run the numbers and figure it out. Are you ready? Let's do some stoichiometry. It's going to be fun. Let's just start by getting our grid set up. All right, we're going to use dimensional analysis to solve these. Here's your first absolute. See this first square? The entire given expression is going to go there, always. All right, so that whole given expression is going to go right here. (150 grams of O2). Now, before I even look at my STOIC cheat sheet on what's going to happen next, I bet you can already tell me what letters are going to go down there. Which letters? Which letters? Grams of O2. All right, the exact same letters are going to repeat themselves. Grams of O2. All right. Take a look up here at the paper. All right. Since we were not given moles, we're going to start way out here. All right. We're not starting here because moles was not given. We're looking here. Hey, which of these three rectangles deals with grams? The top, middle, or bottom? The middle. It says mass, right? Grams is mass. So we're actually starting right here. If you look at that square, it tells you exactly what you're supposed to do. Right? It tells you the next item that would go in here. But if you look at your steps, we're supposed to be converting the given to moles. So, what unit will I put up here to turn this into moles? Moles of the given. Just like that cheat says to put in that square. And in this step, we will use our conversion factors like we have in the past. So look at that paper and you'll see that the conversion factor for moles is 1, and the conversion factor for grams is periodic table. In this case, periodic table of O2. 1 O is 15.999, 2 O's is 31.998. Now, we have gone from here, the mass, over to here, moles of the known. We started right there, and we did this math to get to moles of the known, which is what it says I need to do. We need moles of the given. Now we're ready to go across this middle square to get over to the unknown, the other compound that we're dealing with. And we're going to go through that middle square. But before we even look at what's in there, I bet you can tell me the letters that go in this new square. What letters? Mole of O2, because they always copy themselves. Now, I want you to focus on that middle square. Look at your paper. All right? I want you to focus on this middle square, and I want you to look at what it says. It tells you exactly what we're supposed to do at this point. It says that the mole of the known should go on the bottom, and above it, mole of the unknown. Do you see where it says that? Mole. And now I can focus on the unknown. The unknown is NO. These numbers are going to come from somewhere different, though. I didn't mention it previously, but look at what I have it labeled. I have an arrow pointing to that middlemost square, and it says COEF. What do you think COEF stands for? The coefficients. Label it if you didn't the previous time. But anytime mole is over mole, the numbers will be the coefficients, which is why you must have a properly balanced equation, or you've lost this game way before you've gotten to this point. On the bottom, what's the coefficient of O2 up here? It's 5. On the top, we want the coefficient of nitrogen monoxide. 4. Now, by getting those squares filled, we have moved from here across to here. We've moved from here to here. Now, hey, look, sometimes we get to end here. Sometimes we are done putting numbers in the grid. The times that we're done is if moles is the unknown. We're done if moles is the unknown, which in this case it is. We don't have to input any more numbers, because this will give an answer. Look why. Look here, look here. Grams of O2 on top, grams of O2 on bottom. It'll disappear. Moles of O2 on top, moles of O2 on bottom. It'll disappear. So by running the grid, we're going to be left with moles of NO, which is exactly what the problem is asking for. If you remember how to do this, you multiply across the top and get a number. You multiply across the bottom and get a number, and then divide the top by the bottom. See if you can run that calculation. We'll head to Aspen. Do you have an answer? Don't forget your sig figs. They do matter here. What did you get? This 0 is significant because of the decimal. 3.75 moles of NO. Now, should this still feel foreign to you? Absolutely. We've only done one problem, but you'll see it'll start to get easier from here. One thing I do want to let you know before we start our next one, though, is that there's a bit of vocab here. You see that answer we got? We call him a theoretical yield. The answer to any stoichiometry problem is a theoretical yield. You don't have to write that down, just point the arrow to the answer. But the answer to any grid is called a theoretical yield. Write this down. Again, I'd like to point out that I've already balanced it for you. I don't want to trick you into thinking you don't need to make sure it's balanced, though. Hey, by looking at the information I have up here, do you think this will be a longer or shorter example than the last one? How do you know it'll be longer right away? There's no moles. All right, remember, whenever mole shows up here, it means we get to start later. Whenever mole shows up here, it means we get to end earlier. What would be the best type of problem then? Starts and ends in moles. There are problems that give you moles and ask for moles. And you finish them so quickly that you second guess yourself. You're like, I couldn't possibly already have an answer. But moles to moles problems are super short. But problems that don't have moles are the longest, because problems that don't have moles make you start way over here and end way over here, making this the longest type of problem. So, with that terrible warning said, let's get our grid ready. Aspen, what number always goes right there? Or what, I'm sorry, not even number, what expression always goes right there? Yeah, the entire given. All right, so I'm going to put 290 grams of aluminum. Now, before I even analyze what to do next, new Aspen, what letters go in that square automatically? Grams of aluminum. All right, we know right away that it's going to repeat. And now here's where we can look at where we stand. All right. Again, we were given grams just like last time, so that's a similarity. So we're going to go from here through to there. All right. We're starting here, and we want to get to there, and that square tells you what to do. But as the step says, we're converting our given to moles. All right. These two things are the exact same thing, just written in different ways. So I want to go from grams in this first step because I have to have moles of my given. You must start with moles. You can look at that cheat sheet. It tells you in the box what to do, or go straight to your conversion factors on the back, and you'll see that the conversion factor for moles is 1. The conversion factor for grams is periodic table, which would be the PT of aluminum, 26.982. Everybody okay so far? Those squares get us to here. All right, we went from here to there. We went from here to there. Now I'm ready to go from here to there. It takes us through that central square. Or, look at your rules. Next, we're going to convert the moles of the given, which we now have set up, to moles of unknown. Moles to moles. Traveling from here to there. Now, Aspen, I bet you can help me quickly, though. Oops, messed up my colors. What letters will automatically go down there? Of aluminum. It'll repeat moles of aluminum. All right, there we go. Now again, focus on that middle square. Look at your paper. Focus on this middle square so it's not confusing. It tells you what we're converting to. Moles of known to what? Moles of unknown. Moles. This time the unknown is aluminum oxide. Cluster 3, seat 1, what number do you think goes there? The correct answer is 4. Same person. 2. The reason she chose those numbers is because when moles are over moles, it's the coefficients that create the values. The coefficient of aluminum was 4. The coefficient of aluminum oxide is 2. In the last problem, we got to stop here. We were done because now we have gotten to a square that you can sometimes be finished in. But the reason we got to end last time was because it was asking for moles. Is this problem asking for moles? No. So instead of getting to stop here, we're going to go to liters, which is down here. It's going to cross us down to volume. And that's where we'll tell you what to do. All right, but quickly, I bet cluster 3, seat 3 can tell me what letters go here. Careful. What letters go in the diagonal? Moles of Al2O3, because they always repeat. Moles of Al2O3. All right, but now you can answer your next question. Remember, we're trying to do our final conversion. These rules say, if you're doing this part, that you need to convert to whatever you need. Up top, it's whatever you need to finish the problem. In this case, it's liters of Al2O3. Again, use your conversion factors, or just look at the square you traveled through on this roadmap thing. The conversion factor for liters up top is 22.4. That's a new value for you, I know, but I'm going to give it to you. And the conversion factor for moles is 1. See if you can find an answer. Multiply twice, divide once. Keep sig figs in mind. Aspen, whenever you have an answer, you can share it with us. Perfect. Well said. She said 120 point. All right, would fill in the question mark. She left the decimal there because it makes that 0 significant, which is good. We want 3 sig figs. If you did not get 120, then I want you to run it again, because it's just, there's so many numbers here that there's a lot of room for error. What are your initial impressions of this? Now, the good news is this is the longest type of problem. All right, one that has moles nowhere in the given data. Hey, what's another name for that answer, 120? A theoretical yield. Yes? Because every set of squares are equal to each other, like 1 week equals 7 days. And I know that 1 mole of aluminum is the same thing as this many grams of aluminum, just like 1 mole of aluminum oxide is the same thing as this many liters of aluminum oxide. They're set completely even to each other. That's what this is. This right here are 4 things that are equal. 1 foot equals 12 inches. Is there anything to be happy about with this problem? Yeah, there's moles. So we know right away it's shorter than the last one we did, at least. All right? So let's get our grid ready. I know that my given expression always goes right here. So I'm going to start right away with 7.7 moles of hydrogen. I also know that whatever letters are here will automatically go down here. And now I want to analyze where I am in the process. All right? As far as my steps go, hey, I didn't have to do step 1 because your teacher's awesome. I didn't have to do step 2 because my given is already in moles. So we're already here. You just got to keep your bearings on where you are. Sometimes this board confuses you because you don't always have to do all the steps. And I understand that. But you just got to figure out where you're at. And right now I'm here. Or you could look at it as your given moles, so you're starting there. So right away, you're going across this middle area. Right away, you're traveling from here to here, which is when I tell you focus on that middle square to write the correct thing. I want to go from moles of known, as the very middle square says, to moles of unknown gold. Aspen, what number should I put in that square? 3 is correct. Aspen again, what number should I put in that square? 2 is correct. When mole is over mole, the numbers are the coefficients of the elements. Any questions on that step? Sometimes, it's fine. Sometimes we get to end right here. If the unknown is moles, we would be done based on where we are in our roadmap. But the unknown's not moles on this one. So I'm going to right away put the letters again as a copy. Moles of gold. And now I want to orient myself with where I am. All right, my first calculation got me to there. And now it wants atoms, which is a line that sends me upward. it sends me from here's where I am, and this is where I want to end. I want to go from moles to atoms, or particles, or molecules. They're all the same, as I've mentioned before. Cash, what number goes there? It is that number right there, but just give me a version of it. Which one? I can't see what you're playing. Yes, Avogadro's number is correct. 6.022E23 is the conversion factor for atoms. 1 is the conversion factor for moles. Careful with scientific numbers in the calculator. Solve it. Avery, did you get an answer? Say it again, 3.1E23. Y'all confirm that answer? E24? It looked weird to me. I couldn't think of what was been doing this all day. Avery, run it one more time. 3.1E24. Now you are making me want to run. Before you put away, look here. Thinking back to yesterday in the poker chips, and based on the data on the whiteboard, how many times does it appear that this reaction would happen? Think in the context of yesterday. How many times would this reaction take place? How many moles of H2 do you need for it to happen once? How many moles of it did we start with? How many times would the reaction happen? Twice. I've given you enough, assuming that we have excess of him, I've given you enough moles for it to happen 2 times. All right, so while we're learning the process, there's some analytical questions I want to get you to also.